Hello, this is Mrs. Scarpel, and in this video I'm going to review graphing linear inequalities. When you graph a linear inequality, it's much the same as graphing a line with the addition of some shading and looking at whether or not your line will be solid or dashed. So we have this equation, or inequality, y is greater than or equal to negative 2x plus 10. This is still slope-intercept form. Negative 2 is your slope, and 10 is your y-intercept. So just like if you were graphing a line, start by plotting the y-intercept, and then apply your slope to get additional points. So this is a negative 2. That means we want to go down 2 and then to the right 1. And we can keep doing this. Take a straight edge or something to graph your line. And because it is a line, we should put arrowheads on each end to indicate that it's going to continue. Now the next thing we need to look at is this is saying y is greater than. So we want to use values that have a y value that's greater than y values on our line. And we could use a test point. I could use 3, 6. That appears to have a y value greater than this point directly below at 3, 4. So if I test the point 3, 6, I'm looking to see if 6 is greater than or equal to negative 2 times 3 plus 10. Simplify that right-hand side. Is 6 going to be greater than or equal to negative 2 times 3 is negative 6 plus 10 is 4. 6 is in fact greater than or equal to 4. So that means this point 3, 6 is part of our solution set. So when we shade, we're going to shade the points that or the side, the half plane that includes that point, which is all of this here. So this is our shaded region. This becomes our solution set. The equal to part is the solid line. So all the points that are on the line, as well as all of the points that are in that shaded blue region, are part of the solution set. Now something else you could use to determine if something is part of the solution set is you could put your pencil on a point on the line and ask yourself, if I'm looking for y greater than this point, which direction would I have to go? Would I have to go vertically up or vertically down? Well, greater than would be up. So that happens to be the same region that we just shaded in. So that's another test we can use. So here's another example where we are going to graph our line starting with the y-intercept of 5. We have a slope of negative 1/4, so that's either down 1 to the right 4, or we could have gone up 1 to the left 4. The other thing we want to notice is this is only greater than. There's no equal to. That means the points on our line are not going to be included, so we need to have a dashed line. Just like when you're graphing inequalities in one variable, we have open circles or solid filled in circles. We have solid lines for when it's equal to, and we have dashed lines. Since we can't exactly leave a line open, we have dashed lines to represent that the points on the line are not part of the solution set. And for this particular solution set, we have y is greater than. Greater than, if I use that test again, put my pencil on my line, greater than means larger. Vertically, that is up. That's the side of my line that I'm going to shade in. So anything in this region is part of the solution set. And again, you could take a point and test. To show the testing, I'm going to actually take a point that doesn't fit in the region. I'm going to take 0, 0 and test to see if that is true. Is 0 going to be greater than negative 1/4 times 0 plus 5? Well, negative 1/4 times 0 is 0, so we're left with 0 is greater than positive 5. That is not true. So that means the point 0, 0 is not part of the solution set. And if we look, the point 0, 0 is not in our shaded region. And the last example. Again, it is in slope-intercept form. Makes it just a tad bit easier for us. I can start by plotting the y-intercept at -8. Our slope is 2, so that's up 2, right 1. It does say less than or equal to. That means our line will be a solid line because of the equal to. And this is saying that y is less than if I'm looking for y values that are less than, I would go down vertically for the less than. Again, we could also use the test point. I'm going to use 0, 0 just because it is a quick one, because anything times 0 is going to be 0. Is it true that 0 is less than or equal to -8? That is not true, so we do not want to shade in the side of the graph. That includes the point 0, 0. We do in fact want to shade where I drew that arrow down. So our solution set includes all of the points on the line as well as any points that would fall into this shaded region. And that is how you graph the solution set for a linear inequality.